The title of this webinar, as Gail has already mentioned, is Best Practices in Patent Research, How to Get the Results You Need. When I began my career in patent information in an age before the World Wide Web, you could count on the fingers of one hand the number of patent databases online. Moreover, I don't think there was a single patent search service that was designed for the non-specialist or end user. Today's patent searchers, both occasional and professional, are blessed, or is that cursed, with an abundance of tools. At the last count, there were over 100 patent research solutions available to choose from around the world. These include the free-to-use databases offered by many of the world's intellectual property offices, such as the European Patent Office's Espasnet, as well as organizations like Google and not-for-profit institutions like Cambia. And there are, of course, the commercial, usually subscription-based tools offered by information providers such as LexisNexis and others. As with most things we do at work and in the home, it's always better to use the right tool for the job. But leaving aside the free tools, the pros and cons of which we covered in a previous webinar, and I have included here the URL to that free versus fee-based patent research webinar. In practice, most professional searchers have access to only one commercial tool, usually the one that's been selected by the law librarian or information manager for the firm or company. Rarely does any single tool offer the user everything, so compromises usually have to be made, and of course budget often plays a large part in the decision of which tool to buy. How does the saying go? When the only tool you have is a hammer, everything looks like a nail. Well, one of the goals of today's webinar is to allow you to use the hammer as more of a precision instrument. My experience has shown that no two patent research tools are alike. They all have different strengths and weaknesses, be it the breadth and depth of coverage or the range of features and functions on offer. But the types of patent searches undertaken are fairly standard, the most common being novelty searches to determine whether an invention already exists, validity searches to find prior art that might invalidate an existing patent, infringement searches to establish that a product doesn't violate any in-force patents, and state-of-the-art searches to see what's being developed in a particular field. We don't have time or the resources to go into every one of these types of searches today, but the principles we're going to use can usually be applied across the range. The subtitle of the webinar is Command and Control. And while I've conducted my searches using LexisNexis TotalPatent One, what I'm aiming to do with this session is to put you in command by allowing you maximum control pretty much regardless of the tool you have access to. Keyword searching is where most searches begin, and all tools support keyword searching to a greater or lesser extent, with some offering more sophisticated search interfaces than others. For example, and depending upon the content, most professional tools allow the users to restrict their search to particular textual elements of the database, like the title, abstract, and claims. Some go further and support searching the first claim or independent claims. Full-text databases allow the user additionally to search elements like the description and even examples and tables. The type of search the user is conducting will often determine the content they need access to. Infringement searches, for example, require close scrutiny of the claims of each potentially relevant patent, but only those that are in force. So a database that allows users to search and retrieve the claims for granted issued patents within the last 20 years is preferred. Let's begin with a simple novelty search for a folding bicycle that hinges around the frame. Something like these. For my first example, I'm going to look for documents that contain the terms collapsible bicycle frames. When searching any tool by keywords, remember that the inventor, or more often the person who wrote the patent application, may not have used any or all of the expected terms in the application. It's always best, therefore, to provide the tool with as much information as you can to increase your chances of finding relevant documents. One way of finding suitable alternative terms is by reviewing the titles and abstracts of sample documents. From these screenshots, I can see that alternative terms for collapsible include portable, folding, foldable, and compactable, but I've also found collapsible with an A. I don't know whether that's a typo, but we may need to include it. For a bicycle, I can use bike and cycle, and for frame, I can use structure. The moment you include more than one term in your search, you have to ask yourself, how do I want these terms to appear in the documents? Do I want to see only documents that contain all of the terms, or only some of them? Am I looking for them to be retrieved as an exact phrase? Is it important for terms to be adjacent to each other, such as in the same sentence or paragraph? Or am I content simply for them to be present? Lastly, are there any terms that you don't want to see? This means you need to consider the relationship of the terms to one another using what's known as logical Boolean operators such as and, or, and not. And possibly proximity operators like near or within. The precise use of operators and their availability will vary from tool to tool, but all professional tools should offer some kind of logical and proximity operators. Using operators, also known as connectors, requires the user to tell the search engine how to structure the search and how to prioritize the various terms. Most search engines do this using parentheses, and the order in which parentheses are used has a major bearing on the results. As well as using operators, you should consider using any wildcards that the tools support. Wildcards are symbols that substitute for one or more characters, usually to broaden a search. Using our search query collapse asterisk would also find collapses, collapsing, collapsible, and collapsible with an A. Some tools also offer what's called left-hand truncation, so a search for asterisk cycle would find bicycle, as well as motorcycle, unicycle, and tricycle, but would also bring back documents containing the term recycle. Stemming is another useful feature to aid retrieval by keywords, and today's tools often apply stemming automatically. This means that a search for collapse would also automatically retrieve documents containing the term collapsing, etc. Some tools allow the user to enable or disable stemming, but for those that don't, enclosing the keywords in quotation marks, thus collapsible bicycle frame, will usually only find documents in which the exact phrase is present. And in the next couple of slides, you can see that we have collapsible bicycle frame showing up in the abstract or showing up in the title. A few words of caution when using keywords. While keyword searching is by far the most popular form of searching, especially among end users, it does have its limitations, not least in the text itself. It should go without saying that searching international databases using only English language terms is likely to return largely English language documents. But what if we have to search documents published in other languages? Few of us have the skills to construct complex search strings accurately using search terms in various languages. Some tools, most notably WIPO's Patent Scope, which uses CLIR, cross-lingual information retrieval technology, automatically translates the query into English, French, German, Japanese, and Spanish. Most other tools rely on the database being translated, usually statistically by machine, the quality of which has advanced enormously in recent years, but can still leave a lot to be desired. When we ran our collapsible bicycle frames query against the titles, abstracts, and claims of Japanese, Korean, and Chinese full-text patents in TotalPatent One, here is what we got. And you can see that the first two documents contain the term collapsible bicycle frame, either in the title or in the abstract, and these particular examples are Chinese utility models. Another factor to bear in mind when searching even English language collections by keyword only is the quality of the text, especially the full text. While we may take full text databases for granted these days, remember that these emerged relatively recently and that some full text databases have been generating using optical character recognition or OCR scanning technology. OCR, like machine translations, has improved greatly, but it's still capable of introducing errors into the data, especially from poor quality source data. Things to look out for include occasions when the OCR engine has had problems recognizing where one sentence or paragraph ends and the next one begins. This can lead to retrieval issues, especially when using proximity operators such as within sentence or same paragraph. One of the major advantages of searching patent data compared to other technical documentation is the concept of patent families and equivalents. Once a patent application has been filed with the national office, the applicant has the option to file for protection in other countries around the world. These so-called equivalents claim priority from the initial filing and together create the patent family. There are several definitions of a patent family, including domestic and main, but the one we're going to use here is widely acknowledged to be the broadest definition. The IMPADOC, or extended family, includes all the documents directly or indirectly linked to one specific priority document. Now, it's not the intention of this webinar to go into the concept of patent families and how the various types of family differ, but I wanted to highlight it to show how family documents and equivalents can be used as an alternative or complement to machine translations. Because an invention has to be filed, usually in the language of the national office, and remember, this can be any one of several languages for international offices like the EPO and WIPO, it means that an English language equivalent can often be found for an important invention originally filed in another language. While they're not necessarily direct copies or translations of the original filing, they are directly related, and being published in English reduces the risk of any important concepts getting lost in translation. TotalPatent One is both a records-based and a family-based tool. So it enables users to toggle between results as individual records and as families, i.e. inventions. Users of non-patent literature databases like Elsevier's Scopus will be very familiar with the concept of citations, scholarly papers, books, etc., that are initially referenced by the author and later by subsequent publications. Citations are also a major source of information on patents, and like families and equivalents, can be used to find similar and related documents to help overcome issues with foreign language texts. In patents, the inventor is required to list any prior art related to their invention. This information will often be supplemented by prior art cited by the patent examiner. Several tools offer what's known as a citation map or tree, a graphic that allows users to see at a glance all of the documents related in either direction to the source document. And in this rather poor graphic, for which I apologize, we have both cited and citing patents. Some tools are beginning to dispense with text-based searching and have introduced a feature they're calling semantic search, which aims to analyze the concepts behind an invention and retrieves relevant documents. Be aware when using these tools that many function like a black box and don't make clear to the user the basis on which documents are retrieved or allow the user any degree of control. Similarity or smart search systems, such as the ones used in TotalPatent One, make no claims to using semantic search technology. The similarity check is done by matching a source document to all documents in the database based on the title and abstract only, resulting in a score. The 10 highest scoring documents are then retrieved. By now, you will see that though powerful, as well as easy to use and understand, keyword searching does have its drawbacks. Long before full text became available, indeed, before patent documents were online, many of the larger patent offices developed hierarchical classification systems to categorize their collections by technology. Patent classification is assigned by patent examiners at the most detailed level applicable to its contents. There have been numerous patent classification systems, but today they're becoming standardized around WIPO's International Patent Classification, the IPC, the Japanese Patent Office's File Index and F-term system, and the combined USPTO, EPO Cooperative Patent Classifications, CPC. But many people, professionals and end users, aren't yet familiar or comfortable with CPC. This may not be surprising given that it only came into force in 2013, but I hope the following example will encourage more people to use this tremendously powerful resource, especially as it's being adopted or incorporated by many of the world's largest patent offices, including China and the Republic of Korea. Some tools have incorporated a feature to search and browse all levels of the CPC to find the relevant section, class, and subclass by keywords. Using one of these tools, we can see that collapsible bicycles have been categorized under Section B, performing operations, transporting. Class B62 covers land vehicles for traveling other than on rails, and subclass B62 covers cycles, cycle frames, etc. Drilling down further, we can see that the CPC has a main group for collapsible or foldable cycles, B62K15, and a subgroup for foldable frames, /006, and 008 for foldable about 2 or more axes. So a search for CPC B62K15, 006, or 008 appears to be exactly what we're looking for. But while a CPC search does return highly relevant hits, you should bear in mind that when you search with a CPC symbol, you can only find documents to which a CPC has actually been assigned. I strongly recommend, therefore, carrying out certain searches twice, once using keywords and once using CPC classification symbols. You can then merge the two answer sets together by ANDing to remove any duplicates. Of course, Another way to find records is to look for organizations, assignees, and individuals, inventors, who specialize in the technology you are looking for. Among the leaders in the field of collapsible bicycles are Dehon, founded by David T. Hon in 1982, and the British company Brompton, founded a few years earlier by Andrew W. Ritchie. A search for Dehon or Brompton with no field qualifiers returns too many false hits, partly because the term Brompton is used in many other fields, including addresses, so it's important to restrict the search to the assignee field. Normalization and standardization of assignee names, as well as the grouping together of related organizations, is essential for ensuring that the search captures all relevant entities. LexisNexis has developed a proprietary algorithm for normalizing and standardizing names, and together with offering users the means to search the original and current assignees, gives more options than are usually supported, thus increasing the likelihood of retrieving relevant documents. Searching for inventors is less sophisticated, owing to a general lack of inventor name normalization within the industry, but in combination with assignee fields can usually be relied upon to retrieve relevant hits. And in this slide, you can see that we have indeed found 68 records, the current assignee of which is Dehon Technology Company Limited, and the inventor is listed here as David Hon. These days, most tools offer a fairly comprehensive suite of features and functions, and many include a range of search interfaces from simple, Google-like interface to more advanced search forms with drop-downs that allow the user to restrict their search to particular fields. Some also allow the user to browse specific content like names and classes. Some, though, permit the user to interrogate the database directly using what is known as the command line. This is an extremely powerful mechanism that's underused, in my opinion, perhaps because it requires an understanding of the search syntax, nesting, operators, wildcards, and so on. In order to help users search their database, all providers map the content against specific fields such as the text, names, numbers, dates, codes, classes, and events. These are assigned an alias, typically a series of 2, 3, or 4 letters, to the most commonly used field names. This indexing, as it's known, allows the user to search potentially hundreds of fields compared to the few dozen or so normally listed on the search forms. Examples include DSCDR, which searches the description in the drawing section of the patents. CLMI searches in the independent claims, regardless of the language. And NPC searches all non-patent citations. While not found on the search form, details of the searchable fields for each tool are usually listed in the online help and user manuals. By exploiting this underused information, users can sometimes retrieve records that might otherwise not be returned by a standard search. Using command line functionality on any tool is not for the faint-hearted, as it does require a deeper knowledge of the search syntax, but TotalPatent One has developed a novel way to introduce even occasional searches to the power of indexing through its object search feature. The data model used in TotalPatent One contains over 1,500 different data objects and fields, the most common of which are grouped under a series of headings and incorporated into the guided object search form. If the guided object search is not sufficient, there are many, many more objects in the database that enable experienced users to search and execute their own searches based on the query syntax. The main search elements are fields, combine operators, multiple language search, search operators, and wildcard and fuzzy matching. Understanding the syntax and being able to interrogate the database directly without the limitations of the interface gives the user greatest control. I like to think of it as getting under the hood or bonnet of a car's engine and being able to fine-tune it to suit the driver's needs rather than those of the vehicle manufacturer. Finally, few searches are immediately definitive. Almost all will require some degree of iteration and adjustment, again fine-tuning if you like, to get the optimum set of results. While we concentrated on searching, filtering and browsing are equally important processes that allow the user to scan through their hit list and make adjustments on the fly. Narrowing down by patent authority, publication, priority and filing dates, by assigning inventor names, all help give the user a clearer perspective on their results. And images can be a huge help too. Remember that prior to the introduction of computerized systems at the USPTO, examiners relied heavily on the shoes to find relevant documents. These were literally boxes of patents filed by class and subclass, and experienced examiners simply rifled through these documents, scanning the images. Indeed, when the examiner-assisted search tool EAST was developed at the Patent Office, one of the requirements was for sub-second flipping of images, mirroring the practice of skimming through the shoes. TotalPatent One allows the user to create grids up to 5 by 5 per screen, and to see at a glance the front page image to help determine whether a document is worthy of closer inspection. To sum up then, few of us have the luxury of access to an unlimited number of professional patent research tools, and the ones we do have may only offer access to the abstracts and bibliographic data or a small collection of full-text databases. Some may lack the features and functionality we need to do our jobs efficiently, but all of them will allow the user to search by keywords and by classes, and while it may not be immediately obvious, all tools will index their collections and surface this indexing in some way. You shouldn't feel limited by the search interface, and I would encourage you to experiment with the command line. Families and equivalents and citations provide the means to read documents, often in your preferred language, and images and drawings are published in a universal language. And one day, the ability to search a collection of patents by the drawings will become a reality. Well, that concludes this part of the webinar, so I'd like to thank you for attending. Before I hand you over to Mike Hudelson, who is going to perform a brief demonstration of LexisNexis TotalPatent One, we do have some time for questions, so if I can ask Gail whether you've received any over the chat feature, maybe I can try and help answer them. Maybe Mike can pitch in as necessary. But once again, thank you all for attending. Gail.
Thank you, Richard. And I do have a couple questions. One, I noticed that you have standardized and normalized assignee names. What is the difference?
Okay. Well, this is a development that LexisNexis undertook several years ago when I was still employed there. They recognized that the data as received, the assignee name data as received by the patent offices, whilst standardized by individual patent offices, was not universally standardized, and could be in a mixture of cases, could contain various punctuation marks, and indeed could also include the entities of the organizations, and there are often errors there. So in standardizing the assignee names, LexisNexis standardized everything by, I think it's uppercase. They removed all the entities, they removed any punctuation marks, and any obvious typographical errors were corrected. They then took that newly standardized data a stage further and normalized it by grouping similar organizations together. So if you take the example of IBM, there are hundreds, if not thousands, of listings for IBM within the patent databases. But using the LexisNexis name normalization algorithm, you can find every single patent that has been assigned to IBM simply by searching for IBM, regardless of whether it was listed as International Business Machines or IBM or IMB, or indeed any of the subsidiaries of IBM could be found that way. So that's the difference between standardization and normalization. Hope that answers the question.
Thank you, Richard. Another question we have is, when do we know when to stop a search?
That's a very good question, because you do have to stop a search. And a few years ago, I attended a conference at the European Patent Office, and all of the patent examiners are indeed encouraged to stop a search. One of the things you may do is you may set a time limit. If you're contracting out your searches, then you may set a cost limit. And once that has been reached, that brings a halt to the search. But at the end of the day, the user has to determine for themselves, have I explored every conceivable channel to find the best possible results? And there is no such thing as the perfect result. Sadly, the perfect set of results. Sadly, not all of the patents are available online. And of course, when searching for prior art, you're also searching through non-patent literature, journal articles, books, conference proceedings, grey literature, and you don't necessarily have access to all of that. So it has to be a judgment that an individual user takes at the end of the day, but the time does come when they have to stop searching, especially if iterating that search still further is taking them further away from where they want to be. Most people would say that you simply cannot read more than maybe a few dozen, a few hundred patents. So, perhaps that's going to be the sort of cutoff. You have to get it down to a quantity of documents that you can then analyze.
Great, thank you. Another question, I use IPC, not CPC. Can you tell me why you prefer CPC?
Like I suspect most of the people on this call, we were brought up using IPC. The Cooperative Patent Classification System itself was derived out of ECLA, the European Patent Office's classification system, and the USPTO's US Patent Classification System. ECLA was derived from IPC. But CPC has come so much further than IPC. So, amongst the reasons now that I prefer to use CPC over IPC is update frequency. I'm not sure how often IPC is updating these days, but it used to be annually. CPC, when it was launched, aimed to update much more frequently. Every month was their initial aim. Then when you look at the actual scale of CPC compared to IPC, in terms of subclasses, there are marginally more subclasses, I think, than there are in CPC than there are in IPC. But in terms of the symbols, there are actually more than twice as many. IPC was some 70-odd thousand symbols, and when it was launched, CPC was over 160,000. So it it is just that much more granular than IPC. And so it is my preferred classification tool of choice these days.
Interesting.
But there are some drawbacks to it. Not everything has been classed by CPC. It does take time to apply CPC. So there are times when you will have to use IPC simply because the CPC has not yet been applied.
Thanks, Richard. Also, do you use U.S. codes?
U.S. classes, I'm assuming they mean by that. I can't say I do any longer. Again, prior to the introduction of CPC, then yes, I used to use a U.S. class, a subclass. And that's because I'm not sure that IPC was being applied accurately, consistently, necessarily across U.S. patent classification. And so I tended to rely upon U.S. class then, but that system has now actually been abandoned, I think, since 2015. And so I use CPC when searching that data. I think I'm right in saying, although it's a few years since I left, that LexisNexis has retained the original classes on the documents, but of course they have not been updated. This is something that Mike may be able to comment further on.
Yes, that's true, Richard.
Okay.
Okay, and I have one last
now
question.
a good time to hand over to Mike?
Yeah, just one last question, which is you talked about object search. What is the purpose of object search, and will that be expanded in the future?
Why don't you go ahead and hand it over to me, Richard, and I can talk a little bit to that and show that a little bit.
Let me do that. So here we go. So Mike, I'm going to make you the presenter. Hopefully you have it.
I do. Let me share my screen.
We're seeing it, Mike.
You are seeing it. Okay, great. We'll take a few minutes here. Not going to go through an extensive demo, but did want to just touch on a few different things. Objects, as you see up here, you can turn these on, and this is where these appear. Really what these are for is for users who do not regularly conduct really long, intricate search syntax strings, but want to have the system help them, in essence, to build a query. And there are several things in here, obviously, that you see, names, dates, classes, etc. Within here. And also one thing we have put in here is, that is in object search, is if you start typing ahead, you'll see it will expand a list for you. When you're doing your own command line query, this doesn't happen. So again, this is just a little search aid for users that they can use of object search. We will be adding more objects in the future to this, and one of the interesting things that we plan on doing is, and the reason why we called it a object search as opposed to what is often called a field search, is that while today it is fields that are contained within a patent document, in the future what we plan to do is let users save particular query strings as objects that then they can pull up and easily repurpose. So you don't have to restart a query. You'll be able to save query strings that you use frequently and put those directly into a search. So that's one of the things that we'll be doing. Also, something else that we'll be doing is adding additional objects that will enable you to search, for example, within your folders from here, to search within annotations, to search within saved searches, and so forth, so that you can really use them as all-purpose searching, not only to query the database, but also to query your own work product that you've saved. So one of the things that we're really trying to do with TotalPatent One is streamline a lot of processes for folks. As you can see, any of you that have used TotalPatent before, the user interface is much more streamlined in that way. And a couple other things that I'll touch on. We do store all the documentation here under the little question mark, user manual, quick reference guide. We have guides in foreign languages as well. That's going to be a big push for us in the future. I'll talk a little bit to that. A couple other things, if we go to our preferences pages here, you see, for example, fields that you can choose for your results list. Excuse me. That will be expanded. We'll add some additional fields to that. The keyword occurrence feature, Richard talked to that and showed that with your color coding there. Family. We have 4 different family types, and when you click on one, it gives you a definition of that, so you can choose that for your filtering tool with your family's publication toggle switch that was shown in one of these screen captures earlier, along with your date and your preferred representative member. And again, everything in here we've made very easy, click and drag. If I want EP at the top, then WO, then US, I could do that. If I want to put it back to the way I had it, I can do that. You click Save and Close, and it would automatically update and save your preferences for you. One of the other things that we're doing going forward, you'll see here now user interface display language, document display language. We're going to be adding search language here as well. There have been a lot of enhancements that have been made in this area in terms of language, translation, using neural networks for translation. So we're doing a lot of things in here where we're going to be releasing a number of customized user interfaces where the user can choose their particular language, both for search, for display, for export, etc. And of course, if we go back over to search and we take a look at our list here, 107 different authorities from around the world, all of these we do English machine translations from the filed language if it was filed in something other than English. So we're already doing that, and what we're going to be moving forward doing as well is doing the reverse, where we're going to take English language documents and start translating those into foreign languages for searching as well. So there's a lot coming in that way. Finally, one of the other things that I'll touch on briefly, just because it's hard to show this in a screen capture from a PowerPoint that Richard had, is the technology used to build TotalPatent One is Angular technology, where we incorporate what I call single-page application, or SPA, within here, so that when you run a search, you notice what happens there is it slides over and automatically gives you your results. Everything happens within a single page. You see, if we go here, this will take us back to split screen, and we're on our filters, so our graphical filters. If we wanted our search shown instead, we can do that. Slides in, slides out. If we wanted to go back here, we can do that. If we wanted to open a document, we can open the document. It'll slide right in. If we want to make the document in full, we can do that. We can always go back to our split screen view here. We want to go back here, split screen view here. So everything takes place within a single page. You don't fall down a rabbit hole of wondering, how do I get 3 steps back? I don't remember what I did, and I can't remember what the command is. No, everything here is built to be not only very user-friendly in terms of the flow of everything sliding in and sliding out, but also you've got the capability to not have to know any commands. Everything will slide in, slide out for you. It also helps with speed. Things load very fast comparatively to the TotalPatent, for example. Everything will slide in and slide out. So you can always have a split screen view or a full screen view. If I wanted to go back, full screen view for search, very easy to do that. If I want to go back here, split screen. Telescopes in, telescopes out. Wanted to show that because that's really something that you can only appreciate if you see it dynamically as opposed to a static screenshot. So for the future, we're going to be adding a number of additional things in here, more graphing and charting, more analytics going forward. So there's a number of things that are going on from a development perspective. So this was just designed to show you just a little bit of how it looks when you're live within the app, because that can really you can only really grasp the how we built this with the single page application technology if we flow in and flow out. Then your little icons here, you see the red line that lets you know you're on search. If you want to go into your folders, if you wanted to go to your saved searches, your downloads, your alerts, and your preferences here. So it's very easy to navigate the system. It's a clean UI. It's very user-friendly in that way. In many different places, we put in icon symbols with the pop-up there that lets you know what it is. This enables us to present something very clean and very intuitive to a global audience, because we do have users of the tool around the world. So that's just a little bit of what I wanted to talk to Gail. So let me ask first, are there any other questions that have come in via the chat? And if not, I'll put up some contact information.
I think you can go ahead and put up the contact information. There aren't any other questions that I see.
Okay.
So we can look at that for a minute, and I want to say thank you to you and to Richard for the good information you shared today with our audience, and to the audience for being part of this webinar. And
Sure.
a reminder that this has been recorded, and so you will be receiving a copy of the recording and the slides as well after it is available.
Sure.
So I think.
Oh, I'm sorry, yeah. Gail, go ahead.
No, that's okay. Carry on, Mike.
Just wanted to mention, and I'm putting it up on the screen now, my colleague Dustin Seifert. If you have any inquiries, any information, you're interested in the tool, kicking the tires, so to speak, taking it for a test drive, anything like that, please feel free to reach out to Dustin. His contact information here is on the screen for you. That's all. Back to you, Gail.
That's great. Thanks so much. Well, I think we can return a few minutes to everyone's day and look forward to more webinars in the future.
Thank you, everyone.
Thank you. Bye for now.
Bye, everyone.
Bye-bye.